morning, 7th graders. Since I'm not here today, today's video is going to go through what it is that you're going to work on while I'm gone. The first thing you're going to do is we're going to do some class notes, where I'm actually going to talk you through a couple of slides here, and you're going to record them in your geologic notes, your guided notes from class. So pause the video if you need to open up that doc, and then come back to the video here for the notes. So go ahead and get the doc, your guided notes for your geologic time or geologic record notes. So get that open now. All right, so the first thing we're going to do is we're going to go through a couple slides here of the presentation. And I know for some classes, especially first and second period, we might not actually be here in the notes. There might be some notes before this slide, the relative age of rock, that we haven't gotten to yet, which is okay. We'll come back to that, and I'll get to that tomorrow with you guys. I know 5th period, I think, is actually here, but the other 2 class periods, I don't think you're right here, but that's okay. So just make sure you're finding the section on the document for your notes where it says relative age of rock, which is after the absolute dating and absolute age slides. All right, so let's go through. We're going to do some notes, and then there's a document for you to work on. And when I come back tomorrow, I'm going to check that you have the notes recorded, and I'm going to check that you were working on the document, and that'll get you some completion points for the second quarter, some easy points to start the quarter off by just doing what you're supposed to do while I'm out here. So let's go through and talk about relative age of rock. At any point here, since I'm just kind of talking, if you need to pause the video to type, just pause the video to type it and move at your own pace as we go through this. All right, so the law of superposition is a concept that's going to be important for the next part of this unit, and that's understanding what's happening with the rock. So in the law of superposition, what is understood is that horizontal rocks, especially those that are sedimentary rocks, the rule is, or the law is, that the oldest layers are on the bottom, and each layer that's above it, okay, is going to be younger. So each higher layer is younger than the one below it. And so when you look at the picture here to the right, the Grand Canyon, the oldest rocks are down here at the bottom, and then younger, and then younger, and then younger, and then younger. If you think about it, logically, that makes sense, that the oldest rock would be there first, the newer rock would come and be on top of it and push the other one down. And so as you would dig deeper, or in this case with the Grand Canyon of what's exposed due to the erosion, you can see the different layers of the rocks, with the oldest being on the bottom and the youngest being on top. That's the law of superposition. Okay, next, sometimes that rock doesn't end up being undisturbed over time. Things happen. Okay, so one of the things that could happen is that plate tectonics could happen. Plate tectonics could happen. And so forces from plate tectonics can cause rock layers to fold, to bend, to break, which are called faults. And whenever you see any of these folds or these faults, these cracks in the rock, you have to assume that they are younger. Okay, they are younger than the actual rock layers that they broke, or faulted, or folded, okay, or bent. And again, that should make sense, because how can you break or fold something that's not there? Well, you can't, right? You can't. So the rock has to be there first, which makes it older, and then the crack or the bend comes. Okay, and so the rock's there first, then the crack, then the bend. Okay, either one. The rock has to be there first, though. Otherwise, there would be nothing for it to crack or bend. So that should also make sense. Okay, there's a fault. And if you look here, here are your layers in different colors. So the oldest layer is this one here on the bottom, then the gray, then the orangish brown here. And when you look at it, because of this fault, the gray is no longer, and the bottom 2 layers are no longer lined up together. So this fault right here is older than all three of these layers because all three of these layers had to be there before this fault came to move them. Again, that should make sense. The rock has to be there before it can move it, or break it, or bend it. Okay, there's a picture of it nice and clear there in real life, not just a diagram. As you can see right here with the gray rock here that there was a fault that caused those rock layers to no longer be perfectly aligned. Okay, we're looking at igneous rock now. Remember what igneous rock is. Igneous rock comes from magma beneath the surface or lava above the surface. You can have what are called extrusions. So extrusions come out of the ground and they're erupting and cooling on Earth's surface. So usually like by volcanoes or fissures. And then intrusions would happen beneath the surface. Again, this melted rock would somehow find a path to kind of cut through some of the layers of the sedimentary rock and melt it and then cool and harden, and now you have new igneous rock in there as well. So just like faults and bends, any type of intrusion or extrusion is going to be younger than the rock that it cuts across. And again, that should make sense, right? If it's going to come up and push through and melt rock, that other rock had to be there for it to come through to cover up or to melt. And so it has to be younger. So when you see an intrusion, you have to pay attention to how many layers, what does it cut through, and then wherever it cuts through, you know that intrusion is younger than the rock that it has cut through. Okay, so when we look at this picture here of rock layers, and we're trying to figure out the relative age of these rocks, you know the law of superposition is that you would start at the bottom, so E is the oldest. But the next oldest is going to be B, because B cuts through E, but it does not cut through layer C, layer D, or layer A. It only cuts through layer E, and it stops right there. So E is the oldest, then B, then C, then D, and then A is the youngest because it's on top. So you can see both the law of superposition here and this law of cross-cutting, which is where the intrusions are younger than the rock that they cut across. Now we don't see any faults or bends here on this one either, so that we don't have to worry about any of those. But if we did, we know that the faults or the bends are also younger than the rock that they fold or bend. Okay, and then let's just get this down. So you have the law of superposition, and then this is the law of cross-cutting. Any igneous rock, fault, or other geologic feature must be younger than the rock it cuts across. And that's what we just went through and explained. So when I look at this crazy mess here, okay, none of these other rock layers are labeled, but I know that every single one of these horizontal layers, for the most part, is older than these intrusions that are cutting through. And from there, you just have to see, well, what's on top of what? And it looks like A is on top of B, and B is on top of C, so A would be the youngest, B would be in the middle, and C would be the oldest of those intrusions. But all three of these are younger because they're going over top of all the layers of these horizontal layers of the rock. And according to the law of superposition, if I'm looking at just the layers, this one on top would be the youngest, this one would be the oldest. But even with this youngest one, you still would have these intrusions younger. Okay? Okay. So for the next thing, you're going to go onto the doc that's on Classroom as well. And it's called Finding Clues in Rock Layers. And it goes through law law of superposition, law of cross-cutting, and you're going through and you're answering some questions based off of a couple diagrams I have of um, different rock samples where you have different layers of rock, and you're using those diagrams to go through and complete the dock. Okay, and that's what you're working at today. So I'm going to give you completion points today for when I come to check to see that you wrote down all the notes that we covered right now and that you were working on this dock. The dock is not homework, but I would imagine you should probably finish it in class today. Okay? All right. I will see you guys tomorrow. Have a good day.